Okay, welcome to Intro to C Programming. Today we are going to talk about how we read input from the user. We talked about in one of our previous lectures, if we want to output something to the user, we use a function called printf. Printf stands for print formatted. It takes a string as the first parameter, which is delimited by the double quotation marks, and if we want to print out the value of a variable, after we close the string we put a comma, and then put the names of the variables whose values we would like to print out. We had to put special characters inside of the string if we were printing the values of variables such as %d, %f, %c, and so on. To read something from the user, we're going to use a similar function. Instead of it being called printf, which is for printing something out to the user, we're going to use a function called scanf. Scanf is the function that we use for reading a value from the user. So chances are we're going to have prompted the user to say, please enter a value, and then we're going to have a scanf line where we are going to read whatever value the user types into a variable in our program. The code that I have up here on the slide in front of you right now is for creating an integer. So this line here, int I, this is how I create an integer. The variable name that I've created is I, and then if I want to read that variable, read a value into that variable from the user, I type the function scanf, open the parentheses, followed by the quotation marks. Now here I'm going to have to put the same control character that I used for printing out a value to the user. The control character that I use there is going to be based on the type of the variable that I am reading from the user. In this case I'm reading an integer, and if you remember, %d was the control character that we used for an integer. So I say scanf, open my parenthesis, open the quotation marks, put a %d, that's going to be for reading an integer, close my quotation marks, followed by a comma. Now here is where I have to put the name of the variable into which I would like to read that value. I'm going to read that value into the variable I. I have to put an ampersand in front of the variable I. We're going to learn what that means in a future lecture. This deals with addresses though. When we get to lectures on pointers and addressing, we'll talk more about that, and then you'll understand why we need that ampersand right there being passed into that function. So here we just put an ampersand for now. Understand that anytime that you're going to read a value in from the user, you're going to have an ampersand in front of the name of the variable into which you are reading the value. We then close our parenthesis followed by a semicolon. You are not able to read in more than one value in a single scanf. If you want to read in more than one value from the user, you're just going to have two scanf statements. We're only going to put one control character inside of our quotation marks. You also do not have any other characters inside of there. You're not going to type anything in there. Inside the quotation marks is just going to be the control character specifying the type of the variable that you would like to read that value into. And then after your comma, put the ampersand followed by the name of the variable into which you would like to read the value. We have all of the same control characters for reading values in as we had for outputting in our printf statement. So you see here that we have the %d or %i are used for signed decimal integers. We typically use %d for that one. We can read in octal values from the user with a %o. We can read in decimal values that are unsigned with %u. %x will read in hexadecimal values for us. %e will allow us to read in floating point values in exponential notation, which would be something like 7e6, and that would be equivalent to 7 times 10 to the 6th power. So we can read in values in exponential notation if we want, and then one of the other more common ones that we use is %f. That'll allow us to read in floating point numbers. If we want to read characters, that would be %c, similar to how we could output a character with a %c in the printf. And then we will also get to strings in the future, and for that we would read them in using a %s as in string. To format our output now, some of you who have been playing around with printing things out to the screen, if you ever print out doubles or floats, you may see that the precision is a little messed up. So look at that first example that I have here, where I say double num equals 192.13, and then I print out a %f followed by a new line character of the value num. This is actually going to output to the screen 192.130000. The reason for that is because of the precision of a double. The precision of a double is higher than just 2 decimal places, so it's going to put zeros after that to show you just how precise the number actually is. If you would like to print it out with just 2 decimal places instead of having all of those zeros following it, we can do that. Just inside of the %f, between the % sign and the f, we can put a .2. And that's going to say after the decimal place, I want 2 digits. And then that'll just chop it after that. It'll give me a 192.13. So it'll make it nice and formatted for us, easier to read. This is very useful to do, especially if you have numbers that are very, very long, or if you're performing divisions with floating point numbers. You often will have a value, even though it might seem like the number should come out to be 13.40, it'll actually come out to be 13.399999, and that's just because inside of our computer we have some kind of a precision that all of our floating point numbers use. So it's often nice to do this where you can just truncate it and you will get the number of decimal places that you want. Just by doing this little trick here, when you print it out, you're going to have the percent sign in between the percent sign and the F, put a dot followed by how many decimal places you want, and that'll print out just like that. In this case here, if I had done a %.3F instead, it would have printed out the number 192.130. Alright, that's it for this lecture. We will have a program that we'll be writing right now, converting and doing some input and output, so stay tuned for that.